Welcome to the Identifying and Describing Confidential Data module of the Symantec Data Loss Prevention 15.5 Administration course. Organizations are inundated by data in today's network environments, and since it is not practical to try to protect all of this information, each organization needs to determine what data is most important to them and what impact the loss of this data might have on their business. This can be a complicated and challenging task. Before an organization can monitor and prevent the loss of critical or confidential data, they must first define what data they consider to be critical or confidential. This requires the DLP program administrator to work with data owners to identify data accurately and comprehensively. After this definition has been established and specific examples of data have been identified, the organization can configure the DLP product to recognize critical and confidential data wherever it exists on the network. Note that throughout this lesson, we will use the terms structured data and unstructured data frequently. These terms are defined as follows. Structured data is information stored in a database, or any data format that features columns and rows, such as a spreadsheet file. For instance, customer records stored in a SQL database, such as first name, last name, customer account number, credit card number, street address, state of residence, and so on, are all considered structured data. Unstructured data is every other kind of data. For instance, email messages, word processing documents, multimedia files, which can include photos, video, and audio, presentations, and PDF reports, are all considered unstructured data. To cover the business objective for this module, we will be discussing the following topics: identifying confidential data in an organization, configuring Symantec Data Loss Prevention to recognize confidential data, and we'll discuss many of the important functions and features within data loss prevention in order to identify data, such as described content matching, or DCM, exact matching, EDM and EMDI, indexed document matching, or IDM, vector machine learning, VML, sensitive image recognition, as well as custom file type detection. Lastly, we'll discuss using policy templates to create policies quickly and easily. Identifying confidential data in an organization. In this topic, we'll discuss the process for identifying confidential data in an organization and describe how to build a data loss prevention project team in order to establish data protection needs, as well as prioritize the data that should be protected first. The process of identifying confidential data in an organization typically involves the following two primary tasks. One, identifying data owners and stakeholders, and secondly, working with those data owners and stakeholders to review data protection needs, identify types of confidential data, and prioritize confidential data types for protection. The first step to identifying confidential data in your organization is determining who owns data and has an interest in protecting it. An effective approach to this task is to build a task force centered on solid leadership and informed by input from key stakeholders across the organization. Having a strong, dedicated project manager is critical. When supported by an executive-level sponsor and appropriately staffed technical and business enablement teams, the project manager can drive the cross-functional and cross-organizational involvement needed to perform important tasks. These tasks can include defining data protection policies, prioritizing the data to be protected, identifying the most appropriate staff to review and respond to incidents, determining the proper remedial actions, promoting business unit-level responsibility for reducing organization-wide risk, and encouraging a culture of security. This figure here shows what an example task force and their responsibilities may look like. Data protection needs will vary from industry to industry, and even within a single organization, the types of data that need to be protected can vary from department to department. For this reason, it is important to take time to review with department heads and other stakeholders in your organization the types of data they create and use in the course of their day-to-day operations, and assess and prioritize the importance of this data to the organization. To illustrate the types of confidential data that might exist in an organization, here are some examples from two different industries. In the retail world, there are two important regulations that retail companies must comply with. First, local and federal privacy regulations. These types of regulations require organizations to disclose their information sharing policies to their customers and to safeguard sensitive customer data. Secondly, payment card industry, or PCI standards, stipulate that all organizations who process, store, or transmit credit card information must maintain a secure environment to prevent this information from falling into the wrong hands. Consequently, retail companies will need to protect data such as credit card numbers, social security numbers, and personally identifiable customer information such as home address, phone number, etc. Companies in the manufacturing and high-tech industry, however, will typically focus on protecting intellectual property, which can include product formulas, technical designs, source code, manufacturing procedures, competitive analyses, and product roadmaps. It is usually not difficult for organizations to create a long list of all the different types of confidential data they need to protect. However, rolling out a data loss prevention program can be an ambitious and time-consuming undertaking, so it is often not possible to immediately begin protecting all data at once. Additionally, the loss of some types of confidential data have a far more serious impact upon an organization than others. Therefore, it is a good practice to prioritize data based on the level of impact its loss would have on the organization, and then focus on protecting the higher priority data first. To help prioritize data, Symantec recommends detailing the impact of data loss for each scenario you are considering. Some examples might include heavy fines, loss of customer confidence, loss of trade secrets, loss of competitive advantage, negative impact to the brand, and customer attrition. Next, you may rate the severity of each consequence on a scale of 1 to 5, with a 1 indicating low severity, meaning little overall impact to the organization, and a 5 indicating high severity, with significant impact to financial, legal, or competitive advantage. Input from organizational units and executive-level sponsors is critical during this exercise. With the help of those closest to the data and those guiding the organization, this exercise should provide the perspective needed to prioritize the confidential data to protect and to select the 3 to 5 data loss prevention policies to implement first. This exercise will also help provide an idea of the subsequent policies to implement and their order of deployment. To summarize, an effective approach to identifying confidential data in your organization is to build a task force centered on solid leadership and informed by input from key stakeholders across the organization. It is important to learn from department heads and other stakeholders in your organization about the types of data they create and use in the course of their day-to-day operations, and to prioritize the importance of this data to the organization. It's a good practice to prioritize data based on the level of impact its loss would have on an organization, and then focus on protecting the higher priority data first. Configuring Symantec data loss prevention to recognize confidential data. In this topic, we will discuss the purpose of policies and policy groups, identifying the various data detection methods offered by Symantec DLP, and describe the function of group rules and response rules. After the DLP project team has established their definition of critical data and identified who owns the data, and then prioritized which data to protect first, the next step is to prepare to detect data wherever it exists in the organization so it can be protected. In order to detect data, it must first be described so the DLP product knows what to look for. Symantec DLP enables organizations to describe, detect, and protect data through the use of policies, and in this section we will briefly discuss the purpose and elements of policies. Symantec DLP policies enable you to specify the data to detect, and the automated responses you want your detection servers, such as network monitor servers, network prevent servers, etc., and your endpoint agents to execute upon detection. Additionally, policies document and enforce security management practices. Symantec DLP captures incidents when it detects data that violates policy. Incidents contain matches, which are the specific elements of a message or file that violate policy. For instance, confidential text or a particular attachment size or type. You can create policies from scratch or use templates to help you quickly deploy policies in your organization. You can also share policies across systems and environments by importing and exporting policy rules and exceptions as templates. Whether you start from a blank policy or use a policy template, all policies consist of 3 main parts: detection rules, group rules, and response rules. Additionally, each policy must be assigned to a policy group. Detection rules use conditions to describe the different patterns, formats, and contexts in which confidential data can occur within an organization. Detection rules leverage Symantec data loss prevention's detection technologies to achieve near-perfect accuracy in incident detection. These detection methods are shown here in this table and can include described content matching, or DCM, information-centric tagging, or ICT, exact matching, EDM and EMDI, indexed document matching, or IDM, vector machine learning, or VML, sensitive image recognition, which includes form recognition and optical character recognition, and custom file type detection. Each of these methods will be discussed in more detail later in this lesson. Group rules use conditions to identify the users, groups, message senders, and message recipients to whom a policy applies. Additionally, group exceptions enable you to exclude specific groups of users from a policy. Identities can be matched by email address, user ID, IM screen name, and IP address. There are 3 methods for using group rules in Symantec DLP. First, pattern matching allows you to define single-use sender, user, and recipient patterns to match against user identities. Or you can create reusable sender, user, and recipient patterns that can be used across all policies. Reusable patterns are discussed in more detail in the Described Content Matching or DCM section of this lesson. Directory Group Matching or DGM is a specialized implementation of EDM that can be used to detect large groups of users, who can then be included or excluded from detection based on specific identity information. For instance, you could use DGM to detect and include users with a certain employment status, or ignore and exclude users if they reside in countries with strict privacy laws. DGM leverages EDM technology to detect identities that have been indexed from a database or directory server using an exact data profile. To implement profile DGM, your exact data source file must contain one or more of the following fields, which must be mapped to system fields: email address, IP address, Windows username, or IM name, such as AOL, Yahoo, or MSN. Lastly, Active Directory server groups allow you to configure an Active Directory connection and define user groups based on Active Directory groups, or OUs. You can also schedule synchronization with Active Directory, so any changes to a directory server are reflected in the policies. After a user group is populated, it can be associated with sender, user, and recipient detection rules or exceptions in a policy. Response rules can be added to a policy to take automated actions on incidents. For instance, if a policy is violated, a response rule can block the transmission of a file containing sensitive content, or it can quarantine or encrypt the file. Response rules are created, modified, and managed separately from the policies that use them. This decoupling makes it possible to update and reuse response rules across policies. Response rules can be run automatically, or you can configure smart response rules that incident remediators can execute on demand. You can also implement conditions to control how and when automated response rules execute. Policies are deployed to detection servers using policy groups. Policy groups limit the policy's incidents and detection mechanisms that are accessible to specific administrative users. Each policy belongs to one policy group. When you configure a policy, you assign it to a policy group. You can change the policy group assignment, but you cannot assign a policy to more than one policy group. To summarize, Symantec DLP uses policies to specify the data to detect and the automated responses to be executed upon detection. Policies consist of detection rules, group rules, and response rules. Also, each policy must be assigned to a policy group. Detection rules use conditions to describe the patterns, formats, and contexts in which confidential data can occur within an organization. Group rules use conditions to identify the users, groups, message senders, and message recipients to whom a policy applies. Response rules can be added to a policy to take automated action on incidents. Policy groups limit the policy's incidents and detection mechanisms that are accessible to specific administrative users. Described Content Matching, or DCM. In this lesson, we will describe the DCM detection methods, recognize appropriate use cases, and describe how to use DCM in policies. Described Content Matching, or DCM, enables organizations to detect a wide range of both structured and unstructured data. The DCM detection method uses keywords, lexicons, pattern matching, file types, file sizes, sender, recipient, and network protocol information to detect data loss incidents. DCM is useful in situations where it is difficult or impractical to collect and index all the content that needs to be protected. DCM includes rules for detecting content, classification, context, user identity, file properties, and transmission method. Content rules can include any of the following: keywords, which can include simple keyword lists or extensive lexicons, data identifiers, which are patterns with validators that identify common numbers such as ID numbers and credit card numbers, regular expressions, which should only be used when there is no data identifier available for content matching, and classifications, which can include Symantec information-centric tagging or ICT metadata, or tags applied to email messages and common document file types. Context rules can include contextual attributes, such as general, user, data exposure, data transfer, and custom attributes that are captured by supported services integrated with Symantec DLP Cloud Detection Service. User identity rules can include sender-user matches pattern, which will match domain, email address, IP address, Windows username, or IM screen name. In addition, recipient matches pattern can include email address, newsgroup pattern, IP address, and URL domain. File property rules can include file type, where common document files, such as Office 2016 file types, are identified by MIME type or binary format and accurately detected regardless of file extension. File size allows users to set rules about the minimum or maximum size of individual email components, such as the body or attachments, the total file size of all email attachments, or the total count of all email attachments. File name matching can also use pattern matching on the file name or extension. Transmission method rules apply to protocol or endpoint monitoring, endpoint device class or ID, and endpoint location, and these are typically used as conditions in compound rules. Protocol or endpoint monitoring detection rules can apply to Symantec DLP Network Monitor, Network Prevent, and Endpoint Prevent. These rules enable you to detect network messages based on the communications transport method, such as email, SMTP, FTP, or HTTP. Endpoint device class or ID detection rules detect when users move data from an endpoint computer to endpoint devices. The device class or ID names are those that appear in the computer's device management. Endpoint location detection rules enable you to specify whether the endpoint computer is on or off the corporate network. It can be useful, for instance, if you want to associate one detection rule with a stricter response rule, endpoint block for instance, and another rule with a more permissive rule such as endpoint notify, or one with no response rule at all. To add a DCM rule, on the Policies Detection tab, click Add Rule, then select a DCM rule type. Configure the rule by giving it a name, setting a severity level, and set the condition options. The following sections will provide more guidance on configuring conditions for DCM rules. When configuring keyword conditions, observe the following guidelines. First, select case sensitivity and separator options. Note that your case sensitivity selection applies to all the keywords in the list. Second, leave the On Whole Words Only option selected for all languages, including Asian character-based languages. During the detection of keywords, Symantec DLP will automatically detect which language type it is evaluating and match it appropriately. Lastly, you can either type or copy and paste keywords. Do not use wildcards because Symantec DLP does not accommodate these in the keyword rules. Additional keyword tips are available in the online help. Keyword proximity matching detects relationships among keywords based on their distance from each other. It enables users to define a list of keyword pairs along with their proximity value. These detection conditions support wildcards at the end of the word in whole word mode. Keyword proximity matching is available for all detection servers. Using keyword proximity matching, a policy author can define a pair of keywords and specify a word range between them. If the words occur within that range, a match is triggered. For example, an instance of the content matches keyword rule may require that any instance of the words confidential and information occurring within 10 words of each other triggers a match. As an additional illustration, suppose the phrase, "The quick brown fox jumped over the lazy dog," is specified in the Match Any Keyword field, and keyword proximity matching is configured as shown in this figure. Because expression list A contains the words quick and brown, and list B contains the words fox and dog, and the word distance has been set to 5, the following matches are made: quick and fox, brown and fox, and brown and dog. Alternatively, a policy author can use keyword proximity matching to exclude matching words within a specified distance by using the content matches keyword rule as a detection exception. In this case, any occurrence of the words confidential and information within 10 words of each other is exempted from matching. Data identifiers are configured by selecting breadth and optional validators. Breadth can be set as wide, medium, or narrow. Each option detects different patterns and different mandatory validators. For instance, selecting wide breadth for the credit card number data identifier detects credit card numbers separated by spaces, dashes, or periods, as well as numbers with no separators, and it performs a Lund check, which is an algorithm performed on a number to ensure it is a true credit card number. Selecting medium breadth does everything the wide breadth option does, as well as excludes common test numbers, including those reserved for testing by credit card issuers. Selecting narrow breadth does everything the wide and medium breadth options do, in addition to requiring the presence of a credit card-related keyword in the message. To create a data identifier rule, add a new rule to a policy, and then select the Content Matches Data Identifier rule type. Then, from the Choose Data Identifier dropdown, choose the desired data identifier. Next, to configure the data identifier rule, choose a breadth. Remember that a narrower breadth will require more validators. As another example, selecting narrow breadth for the randomized U.S. Social Security number data identifier requires that the text SSN, Social Security number, or SS pound to appear in a document for a match to occur. When editing a data identifier condition, you can click on the More Info link in the data identifier description to see more details on the patterns and validators that are being used. Optional validators can be set to require or exclude beginning or ending characters that might be common in the data that is scanned, or you can require the presence of specific keywords. Additionally, you can perform an exact match data identifier check, which checks for matches against an index you create of a structured data source to find specific values that match a data identifier pattern. Exact match data identifiers will be discussed in more detail in an upcoming lesson. Finally, you can define custom data identifiers. To create a custom data identifier, you specify one or more detection patterns, choose a data normalizer, optionally select one or more data validators and provide the data input if the validator requires it, and if needed, specify pre- and post-validators, such as characters and character ranges that are valid before or after a data identifier pattern. After the custom data identifier is configured, you can then use the custom data identifiers in your policies. You can configure detection conditions to use a regular expression to match on input content. Symantec recommends that you use a data identifier rule instead of regular expressions when possible, because data identifiers are designed for optimal performance and pattern validation. However, there are cases for which a regular expression is the best detection method. In such cases, ensure that you use a regex creation tool such as regex buddy and test your regular expressions thoroughly before deploying the policies to production. Be aware that other comparable detection methods, such as data identifiers, are faster than regular expressions. This is especially true for complex regular expressions that include look-ahead and look-behind clauses. Although such clauses cut down on false positives by evaluating context, for instance by preventing a match on a 10-digit number when the regular expression is supposed to catch 9-digit numbers, they also increase the performance hit. Symantec DLP's classification rules enabled the detection of Symantec information-centric tagging metadata, or tags, applied to email messages and common document file types. These tags can be applied in one of two ways, either through policy-driven processes, specifically by running an endpoint discover scan on users' endpoint systems, and then using response rules in a DLP policy to automatically tag documents that violate the policy, or second, through user-driven processes, for instance by using ICT plugins with the Outlook email client to enable users to select tags and classify their own email messages. An ICT tag consists of three components: the organization, which represents an entire company or logical divisions within a single company; scope, which is typically a functional group such as payroll or engineering, but can be used to identify any grouping that meets an organization's needs. For instance, documentation related to ISO 27000 certification, or classified communications with governmental or military entities such as NATO. Lastly, sensitivity level, which represents the degree of sensitivity of data within the file, ranging from 1, meaning the least sensitive, to 9, representing highly sensitive data. In the tag example shown in this figure, the tag shown here identifies an organization, Symantec, a scope, Symantec's marketing department, and a sensitivity level, marked as confidential. Email messages or documents to which this tag is applied are thus classified as confidential Symantec marketing documents. An ICT administrator will define tags according to terms that make sense to their organization. For instance, a company might want to define their sensitivity levels as public, level 1, confidential, level 4, and top secret, level 9. The collection of all tags constitutes the ICT classification taxonomy. To make use of this taxonomy in Symantec DLP, you must import it from the ICT server into the DLP database. The taxonomy will then be available for configuring content matches classification detection rules. Symantec DLP searches for ICT tags only in supported file types and email messages. Currently, the supported file types in DLP 15.5 are shown in this figure. Classification rules are configured by setting classification parameters in the Conditions section of the Edit Rule page. The content is classified condition generates incidents when a tagged email message or document is detected, and the tag conforms to the ICT taxonomy that was imported into the Symantec DLP database. The content is not classified condition generates incidents in the following situations. No tag has been applied to an email message or document. A tagged email message or document is detected, but the tag conforms to a different ICT taxonomy than the one that was imported into the Symantec DLP database. Or a tagged email message or document is detected, but the tag is in the wrong format. The content matches condition generates incidents when a tagged email message or document is detected, and the tag both conforms to the imported ICT taxonomy and meets the specific criteria selected for the condition. To illustrate how to configure the content matches condition, consider the following scenario. Acme Incorporated does business with NATO and wants to protect all of its sensitive email communications and project documents related to this customer. Acme's ICT administrator has defined a classification taxonomy that includes a NATO classification scope with associated sensitivity levels ranging from 1, NATO unclassified, to 9, cosmic top secret. Acme wants to detect all email messages and documents within their organization that have been tagged with the NATO classification scope and a sensitivity level of 3, NATO restricted, or higher. To meet these requirements, the DLP policy author configures the content matches condition as follows. 1. From the operator dropdown, select is greater than or equals. This detects tagged items that have a sensitivity level equal to or higher than the value selected in the sensitivity level dropdown. 2. From the organization dropdown, select Acme. Note that the term organization in ICT conditions on the Symantec DLP Enforce server is called company in the administration console on the ICT server. 3. From the scope dropdown, select NATO classifications. 4. From the sensitivity level dropdown, select 3, NATO restricted. 5. If the DLP policy author wanted to detect additional tags with the same rule, they could click the OR button to add a new row of classification dropdowns. Each OR statement is evaluated individually. They do not all need to be true for an incident to be created. Note that in the Match On section of the classification rule, note that envelope and attachments are always selected, whereas subject and body are never selected. Also note that as your organization's ICT classification taxonomy evolves, using is less than or equals or is greater than or equals improves the longevity of ICT detection rules. Because these operators are broader and more flexible than the equal and not equal operators, they are more accommodating to additions and changes in future ICT taxonomies. If you use the equals operator for every ICT detection rule, you are more likely to have to edit your policies often. Symantec Data Loss Prevention Cloud Detection Service can perform detection on attributes sent from supported third-party services. Currently, Symantec CloudSoc and Symantec Web Security Services, or WSS, are supported for integration with Cloud Detection Service. And these services can send a combined list of attributes that fall under the broad categories of general, user, data exposure, data transfer, and custom attributes. For instance, a contextual attributes detection rule might capture incidents when Symantec CloudSoc reports that a user with a high user threat score, as determined by CloudSoc, shares a file in Box, Dropbox, or OneDrive with people outside their organization. For supported services that send the relevant data or file content to Cloud Detection Service, for instance, a file shared in Box, you can combine other types of detection rules, such as keyword rules or exact data matching rules, with contextual attributes rules to enhance content awareness and further pinpoint the user actions that trigger an incident against your DLP policies. To configure a contextual attributes rule, select an attribute to detect on, and then select options or enter information specific to the selected attribute. You can detect on multiple attributes in the same rule by clicking the Also Match drop-down list and selecting Contextual Attributes, Cloud Applications and API Detection Appliance only. Complete the required configuration for each additional attribute. This figure shows examples of configuration options that are available for contextual attribute detection rules. Example A shows the configuration for detecting on the application name provided by the integrated service. The drop-down list includes options for Symantec WSS and the various cloud applications that can be monitored by Symantec CloudSoc. Note that securelets and gatelets are types of connectors that CloudSoc uses to connect to the various cloud applications. Example B shows how to configure a rule for detecting on a specific CloudSoc user threat score or range of scores. Example C shows the configuration for detecting when a document is exposed, meaning that the document is either accessible to everyone within your organization or anyone outside of your organization. Example D shows how to configure a rule that captures information about the operating system of the device from which the user performed the action. The attributes available for use in contextual attribute rules are listed and explained in the Symantec Knowledge Base article entitled Contextual Attribute Conditions for the Symantec Cloud Detection Service Detection Rules, which is available at the support.symantec.com website. User identity detection matches patterns and messages from email senders and recipients, Windows users, IM users, URL domains, and IP addresses. To add a user identity rule to a policy, click the Policies Groups tab and select either Sender User Matches Pattern or Recipient Matches Pattern. This table shows user identity types that Symantec DLP recognizes within the Sender User Matches Pattern detection rules. It also includes the protocols or transmission methods to which they apply and the products for which they function. This table shows the user identity types that Symantec DLP recognizes within the Recipient Matches Pattern detection rule, along with the protocols or transmission methods to which they apply and the products for which they function. To configure conditions for the user identity rule, do one of the following. Select the Pattern option and specify the patterns you want to match. Or select the Reusable Pattern option, and then from the accompanying drop-down list, select the reusable pattern you want to match. The main advantage of reusable patterns is to simplify the task of keeping policy rules updated. To illustrate, suppose you have 100 policies that use the same user identity rule, and you need to update that rule. Without Symantec DLP's reusable patterns, you would need to edit all 100 policies individually. The more frequently you need to update user identity rules, the more monumental the task becomes of updating all of your policies one by one. Reusable patterns enable you to create a sender or recipient pattern and add it to as many policies as needed. And when the time comes to update the pattern, you only have one place you need to update, and all the policies using it will immediately have the changes. If no reusable sender or recipient patterns exist yet, You can either click the Create Reusable Pattern link to the right of the Reusable Pattern drop-down list, or you can go to Manage, Policies, Sender Recipient Patterns, click Add, and then select the type of reusable pattern you want to create. Next, enter the information needed to complete the reusable pattern configuration. The system will notify you if the entries are valid or not. Note that the content fields are adjustable by dragging the lower right corner of the content window. Click Save when the configuration is complete. Symantec DLP can recognize over 200 different file types for most documents, including Office 2016 files, based off of MIME type or proprietary binary format. This means that even if users change the file extension, Symantec DLP can still detect the file type accurately. Note that when performing file type detection, Symantec DLP can detect files contained in zip files because it inspects the content of these files, down to several levels of embedded zip files within the main file. For a comprehensive list of file types Symantec DLP can detect out of the box, see Supported File Formats for Detection within the Symantec Data Loss Prevention Administration Guide. File property conditions are useful in situations where a certain file type should never leave the organization, or where they are added as a compound rule when a specific type of match is likely to occur only in certain file types. Note that if you have a specific file type that is not recognized by Symantec DLP, contact Symantec Consulting to create a custom file type. You can specify exact file names to detect, or you can specify file name patterns using the following operators. Use a dot to separate file names and extensions. Use an asterisk as a wildcard to match any number of characters, including none, and use a question mark to match a single character. You can also specify the following file size detection criteria. The single file size option applies to each specified component individually, whether body or attachment. The total attachment file size only applies to SMTP-based email and only considers top-level attachments. In other words, individual files inside an archive file, for instance zip, rar, gzip, or tar, or embedded as OLE objects inside another file, for instance docx, slsx, and pptx files embedded in a Microsoft Office document, are not assessed when calculating the total size of all files attached to an email. Lastly, total attachment file count option only applies to SMTP-based email and only considers top-level attachments, that is, individual files inside an archive file or embedded as OLE objects inside another file, which are not included in the total count of attachments. With protocol or endpoint monitoring, you can configure detection conditions for network monitor and network prevent to monitor and block network traffic based on the protocols Symantec DLP recognizes out of the box, as well as any protocol you add. Protocols can be added in the Enforce Administration console at System, Settings, Protocols. For endpoint prevent, you can configure conditions to monitor and block traffic at the client level, for instance, the local email client. The supported protocols are email, SMTP, FTP, HTTP, HTTPS, including SSL, and IM. Also for endpoint prevent, you can 1. Monitor and block endpoint destinations, such as local drives, CD/DVD drives, removable storage, like USB drives, network shares, printers and fax machines, clipboard, and cloud storage. Secondly, monitor applications on the endpoint. By default, Symantec DLP monitors applications such as Apple iTunes, Microsoft Outlook, and Mozilla Firefox. You can add applications to monitor by going to System, Agents, Global Application Monitoring in the Enforce Administration console. Lastly, you can leverage application reputation information that's provided by Symantec Endpoint Protection to dynamically monitor applications and prevent potentially harmful programs from accessing sensitive files on the endpoint. This capability, called SEP Intensive Protection, is covered in more detail in the Enhancing Data Loss Prevention with Integrations module of this course. Symantec DLP enables you to detect or exclude specific endpoint devices based on the described device metadata. You can configure a condition to allow endpoint users to copy files to a specific device class, such as USB drives from a single manufacturer. Before you can configure an endpoint device class or ID condition, you must add endpoint device configurations at System, Agents, Endpoint Devices in the Enforce Administration console, or by clicking Create an Endpoint Device when creating the condition. Endpoint device instance IDs must conform to regular expression syntax. In Windows, you can find device instance ID metadata in Device Manager by viewing the endpoint device's properties and locating the device instance path value on the Details tab. For example, a device instance ID for a SanDisk USB flash drive in Windows might look like the example listed here at the bottom of the figure. To provide a practical example of how you might use an endpoint device class or ID condition in a policy, suppose you have a set of USB flash drives with serial numbers that range from 0001 to 0005. These are the only flash drives that should be allowed to access your company's endpoints. In this case, you could add the USB flash drive serial number metadata to a policy's exception so that the policy applies to all USB flash drives except for those with a serial number that falls into the 0001 through 5 metadata range. In this way, the device metadata allows for only trusted devices to be allowed to carry company data. The endpoint location parameter defines how the system determines whether the endpoint computer is connected to the corporate network. There are two methods for determining whether an endpoint device is on or off the network: automatic and manual. With the automatic method, Symantec DLP identifies the endpoint as being on the network if the DLP agent is connected to the endpoint server, and conversely, not being on the network if the DLP agent is disconnected from the endpoint server. With the manual method, you must input a range of domain names or IP addresses, and then Symantec DLP will use this information to determine if the endpoint is connected to the network. You can define these criteria at System, Agents, Endpoint Location. When using the Endpoint Location detection rule, be aware that there is also a response rule condition for endpoint location. The decision whether to use endpoint location as a detection condition or a response rule condition has partly to do with resource use. If you include an off-the-corporate network endpoint location detection condition in a compound rule, the system only analyzes other conditions in the rule if the endpoint is off the network. If you do not include such a condition, Symantec always analyzes other conditions in the rule. In the latter case, you can still configure an endpoint location response rule condition to control whether the response rule executes. But in this case, detection will have already been performed. To summarize, Described Content Matching, or DCM, includes rules for detecting content, context, user identity, file properties, and transmission method. DCM is useful in situations where it is difficult or impractical to collect and index all the content that needs to be protected. Content rules can include keywords, data identifiers, regular expressions, and classifications, meaning semantic information-centric tagging or ICT metadata or tags, which are applied to email messages and common document file types. Context rules can include contextual attributes captured by supported services integrated with Symantec DLP Cloud Detection Service. These can include general attributes, user attributes, data exposure attributes, data transfer attributes, and custom attributes. User identity rules can include sender or user patterns, such as domain, email address, IP address, username, or IM screen name, as well as recipient patterns, which can be email address, newsgroup pattern, IP address, or URL domain. File property rules can include file type, identified by MIME type or binary format, file size, and file name. Transmission method rules can include protocol or endpoint monitoring, which detects network messages based on the communications transport methods such as email, SMTP, FTP, HTTP, etc. Endpoint device class or ID, which detects when users move data from an endpoint computer to endpoint devices, or endpoint location, which detects whether an endpoint computer is on or off the corporate network, so specific detection rules can be applied depending on the computer's location. Exact matching. In this topic, we will describe exact data matching, or EDM, as well as exact match data identifiers, EMDI, and their data sources. We'll discuss the appropriate EDM and EMDI use cases, how to prepare data sources according to best practices, and how to use EDM and EMDI in policies. In recent years, more and more large and prominent businesses and governmental organizations have appeared in the news for their failure to safeguard the personally identifiable information of their customers and employees, allowing highly sensitive data to fall into the wrong hands. Not only does this damage the reputations of these businesses and organizations, but it also puts customers and employees at high risk of identity theft and financial insecurity, as their social security numbers, bank account numbers, credit card numbers, employee records, and other confidential data are sold to the highest bidders. Symantec DLP offers two detection methods that enable organizations to exactly match personally identifiable information, or PII, stored in structured data sources. These are exact data matching, or EDM, and exact match data identifiers, EMDI. Symantec DLP's exact data matching, EDM, detection method enables organizations to detect personally identifiable information stored in structured data sources, such as databases or directory servers, or structured data files, such as CSV files or spreadsheets. This data can be added to an EDM index, and the index can be referenced in a Symantec DLP policy, enabling organizations to detect combinations of information, such as customer first name, last name, and credit card number in outbound emails, or in files residing on Windows file servers, and so on. The EDM data source content can be any type of structured data. Besides single-word cells, EDM multi-token support adds the ability to index and match multi-word cells exactly, and enables more accurate detection. Whatever the form of the original structured data, in order to create an EDM index, you must save the data as a delimited text file. For example, a pipe delimited database extract, with a maximum size of 6 billion cells. To detect exact data, Symantec DLP requires a special indexed version of the data. An EDM index is a secure file, or set of files, containing hashes of the exact data values from each field in the data source, along with information about those data values. The index does not contain the data values themselves, so it is absolutely secure. Before an index can be created, an EDM profile must first be configured on the Enforce server. The profile specifies the data source, the indexing parameters, and the indexing schedule. Once you have created the EDM profile, you index the data source and configure one or more detection rules to use the profile and detect exact content matches. Using the EDM index, Symantec DLP can detect exact data in either structured or unstructured formats. For instance, confidential data in the body of emails, email attachments, or files residing in repositories or being copied from an endpoint computer. Here is an example EDM index, created from customer data containing social security numbers and other personally identifiable information. This index can be used for policies to detect when personally identifiable information has been inappropriately included in an email, for instance. After it is created, the EDM index is deployed to all detection servers, where it is used for detection. You can refer to this index in a policy that is configured to detect specific combinations of fields from the data source. The detection server uses the indexing algorithm to hash input content, for instance an email, and then analyzes the hashed content against the index to find matches. If an employee sends an email containing specified data combinations, Symantec detects the confidential data and creates an incident. Note that the EDM index is server-based. If you deploy a policy containing an EDM condition to the DLP agent on an endpoint computer, Symantec DLP will use two-tier detection to evaluate data for matching. With two-tier detection, EDM detection conditions are not evaluated locally by the DLP agent. Instead, the DLP agent sends the data to the endpoint server for evaluation against the EDM index. Consequently, it is not possible to use blocking response rules in EDM policies on the endpoint. EDM requires that the Enforce servers store the index, and that detection servers store the index and then load it into RAM for detection. The index is not loaded into RAM until it is included in an active policy. The Enforce server is often where the index is actually created, although you can create the index on a remote host using the remote EDM indexer. EDM imposes system requirements on both the Enforce server host and all detection server hosts. If you are indexing remotely, enforced server host requirements apply to the remote host on which the remote EDM indexer is installed. On the enforced server, you need enough disk space for IDX and RDX files, and enough RAM for index creation. On detection servers, you need enough disk space to store RDX files and enough RAM to load the RDX files for detection. The exact system requirements will depend on the size of the data source. For instance, a data source with 100 million rows has lower requirements than a data source with 200 million rows. For more details on EDM system requirements, please refer to the Memory Requirements for EDM section in the Symantec Data Loss Prevention Administration Guide. Before creating an EDM profile and index, here are some best practices to consider for preparing the EDM data source. Data sources that do not adhere to these guidelines can result in significant false positives and errors, and ultimately create more work for the DLP team. For standard EDM indexing, the data source should have a minimum of 3 columns of data. However, if you must use only 2 columns, ensure that both columns conform to all the other guidelines set forth here, and that one of the columns contains a distinctive value for each record, such as a Social Security number or credit card number. If you are using 2 columns for matching, consult your Symantec DLP solution specialist or technical support for additional recommendations to ensure accuracy and best performance. The data source should have column names in the first row. This makes it easier to identify the data you want to use in the policies, instead of using column 1, column 2, and so on. If the data extract has entire columns that contain no data, name them NA or blank as the title in the first row, or just delete them from the file, which Symantec recommends. EDM works best with unique values. Avoid including data that you would not likely need for matching. For instance, if your data source includes a states column, you should remove it because there are only 50 states, and including this column can cause considerable duplication in an index of 300,000 rows. If you feel inclined to leave a common field in the data source for the sake of expediency, remember that Symantec DLP indexes all values in the data source, whether or not you actually use them in a policy, and that this can diminish performance in production. Acceptable delimiters are pipe, comma, and tab characters, but Symantec recommends that you use the pipe delimiter. If you use a comma as a delimiter, ensure that there are no extra commas in the dataset other than the delimiter. Note that address fields are a common source of extraneous commas. Columns containing no data will increase indexing time and create a drag on performance during actual detection. Therefore, you should delete empty columns from the data source before indexing. Also avoid indexing numeric fields that contain fewer than 5 digits, because they are likely to yield many false positives. Also avoid including date fields in your data source. Dates are treated like a string, so if you are indexing a date, such as 12/5/2019, the string must be an exact match. The indexer will only match 12/5/2019 and not any other date formats, such as December 5th, 2019, or the 5th of December 2019, or other matches that include dashes or slashes that do not match the original string. Make sure to remove any quotation marks from data values. If you include quotation marks, Symantec DLP only detects these data values when quotation marks are also present in the analyzed content. Lastly, eliminate single character and abbreviated fields from the data source. These are more likely to cause false positives because single characters are frequently displayed in normal communications. EDM policy matching is based on tokens in the index. For languages based on the Latin alphabet, a token is a word or consecutive group of characters. A multi-token cell is a cell in the EDM index that contains multiple words separated by spaces or punctuation, or Chinese, Japanese, or Korean characters along with Latin characters in the same cell. The subtoken parts of a multi-token cell obey the same rules as single-token cells, in that they are normalized according to their pattern where normalization can apply. Inbound message data must match a multi-token cell exactly, including whitespace, punctuation, and stop words, assuming the default settings. Punctuation next to a space is ignored. Punctuation internal to a token depends on the advanced setting lexer.include punctuation in words. For instance, an indexed cell containing the string bank of Acme is a multi-token comprising 3 subtoken parts. During detection, the inbound message bank of Acme normalized matches the multi-token cell, but Bank Acme does not. Multi-token matching is enabled by default. Multi-token cells are more computationally intensive than single-token cells. If the EDM index includes multi-token cells, you must verify that you have enough memory to index, load, and process the EDM profile. Configuring EDM to detect and protect exact structured data in your organization involves two main tasks. First, creating an EDM profile, and then applying the profile to a Symantec DLP policy. In this section, we will provide a high-level overview of these tasks. First, to create a profile, in the Enforce Administration console, navigate to Manage, Data Profiles, Exact Data, and then click Add Exact Data Profile. Then point the Enforce server to a data source file. There are three options for getting the data source file onto the Enforce server. First, you can upload the file directly to the Enforce server during profile creation. Note that while the absolute file size maximum is 2 gigabytes, this method is not recommended for any data source that is larger than 50 megabytes. You can also copy the file to the Symantec DLP data files directory prior to profile creation. The data files directory for Windows and Linux is shown here on this slide. After the file has been uploaded, you can reference the data source directly from the profile creation screen. Lastly, you can specify a file name during the profile creation and then create the data source file after the profile is generated, but before the scheduled indexing time. After the data source has been configured, you can set additional profile options as needed, such as mapping column headings in the data source to data source field values in the EDM index, or performing error checking during the indexing process, or choosing a character that serves as the delimiter in the data source, etc. Symantec recommends creating the field mappings if you are using EDM in a template-based policy rule, or if you are expecting Symantec DLP to check for data errors. For indexes to be used in template-based policies, you can check if the data source lacks any of the expected columns. You can do this by selecting a template from the drop-down and then clicking the Check Now link. The output will inform you whether any expected columns are missing. At the end of the EDM profile creation wizard, you can choose to create the EDM index as soon as the profile is saved, or you can schedule the index creation for a later time. To configure Symantec DLP to detect confidential data against your new EDM index in a policy, add an EDM rule to a policy that references the index. This is accomplished by choosing the Content Matches Exact Data From option and selecting an EDM profile from the accompanying drop-down list. Next, configure additional rule settings as needed, such as selecting a default severity level for incidents where sensitive data is detected, or specify the number of fields required for a match, or specify the field types that can constitute a match. Exact Match Data Identifiers, or EMDI, are essentially validations of data identifier patterns using an indexed data source. As we discussed earlier in the module, data identifiers are patterns with validators of their own that identify common numbers, such as ID numbers and credit card numbers. EMDI adds another level of validation, an indexed data source that contains specific values for the system or custom data identifier type you're looking for. For instance, DLP has a built-in credit card number data identifier that can detect credit card number patterns with a high degree of accuracy. You can increase that accuracy by indexing a data source that includes specific credit card numbers you want to detect, such as your customers' credit card numbers that are stored in a database as part of business transactions. This EMDI index or profile serves as an additional check or validation for that data identifier. EMDI offers the simplicity of data identifier matching, which lets you specify a validation breadth or the number of validators you want to apply when input content is analyzed. But it also offers the performance of exact data matching with its high levels of accuracy. EMDI brings some significant improvements to Symantec DLP's exact matching capabilities. 1. It is available on all DLP detection channels, including disconnected DLP endpoint agents. This means that EMDI provides exact matching on the endpoint without requiring two-tier detection. Second, it supports blocking, user notification, encryption, and other real-time responses on the endpoint. Third, It is secure and memory efficient, protecting EMDI indexes on the endpoint with strong encryption and having a memory footprint about 5 times smaller than EDM. Lastly, it supports both system and custom data identifiers. EMDI is suitable for EDM use cases that involve 2 or more columns in the data source, with at least one column containing highly unique values for which either a system or custom data identifier exists. For instance, suppose you have a data source containing the following columns: account number, routing number, first name, and the last 4 digits of a social security number. In this example, the account number column is a good candidate for the key required column for EMDI matching, because it contains values that are both highly unique and that are also amenable to a data identifier pattern, which in this case would need to be a custom data identifier since no system data identifier exists for a generic account number pattern. Because EMDI mandates that there must be a match on at least 2 columns, you would then specify at least one of the other available columns, whether routing number, first name, or last 4 SSN digits, to match on. Here are some additional examples of possible columns in a data source that would lend themselves to EMDI. Matching driver's license number against first name, date of birth, address, city, and state. Or matching medical record numbers versus first name, and last 4 digits of the social security number. You could also do credit card number matched against issuing bank name, CVV, or card expiration date. Even data sources that have only 2 columns can work well for EDMI. For instance, you might have a data source that has a total of 2 columns, part number and part description. In this case, the part number column would work well as the key required column, corresponding with a custom part number data identifier, whereas part description would serve as the second column to match on. The table shown here itemizes some of the main similarities and differences between EMDI and EDM. As further guidance on deciding when to use EMDI and when to use EDM, here are some additional points to consider. Use EMDI if you already use data identifiers and want to improve the accuracy with exact matching, or you need exact matching and real-time enforcement on the endpoint. Or you need more flexible data identifier detection, for instance, the ability to detect non-standard separator characters. Or you want to use exact matching in an exception. Use EDM if 1. You need to exclude specific column combinations from matching. 2. If you need to use related policy features such as data owner exceptions and the where clause. Or 3. If your data source is very large, for instance, larger than 4 million rows. To ensure optimal performance of EMDI matching, here are some important guidelines to follow. For data source preparation, before saving the data source to a tabular text file, which you will then use to create an EMDI profile, prepare the data source as follows. 1. Eliminate duplicate rows and blank columns. 2. Avoid single characters, quotation marks, abbreviations, numeric fields with fewer than 5 digits, and dates. 3. Ensure multi-token data appears in the form in which it is expected to be encountered in analyzed content. For instance, in fields that contain multiple words separated by spaces, remove all extraneous punctuation. 4. Avoid the comma delimiter if possible. And 5. Include column headers at the top. For columns in EMDI profiles, we will go into more detail about how to create EMDI profiles later in this topic, but here are some tips related to designating which columns are required or optional when you are configuring the profile. 1. Specify 3 or more total columns for a match to reduce the number of false positives. 2. Designate PII columns, such as credit card numbers or bank account numbers, as required, never as optional columns. 3. Limit the required columns to 2 or 3, because production memory requirements increase at a linear rate with the number of required columns. 4. If matching on only one optional column, avoid using low entropy values, such as US states or zip codes, because they increase the likelihood of false positives. It is recommended that, where possible, use additional data identifier validators together with EMDI checks. Symantec DLP applies such validators before EMDI lookup, so they improve performance and increase accuracy. Also, do not designate EMDI checks as both global and policy-specific for a given data identifier in a policy. For a few additional tips, Use scheduling indexing to automate EMDI profile updates. For custom data identifiers, test them to ensure that they are sufficiently accurate. And for endpoint deployments, full disk encryption on the endpoint device is recommended. The process for configuring EMDI is broken out into three main tasks. First, create the EMDI profile. Second, configure the data identifiers to be used with EMDI. And third, modifying the protect.properties file on the enforce server and all endpoint servers. To create an EMDI profile, here are some basic requirements that the data source to be indexed must meet in order to create an EMDI profile. 1. The data source must contain at least 2 columns of data. 2. It must be possible to match on at least 2 columns, because Symantec DLP registers a match upon the detection of a key value and 1 or more related values within a configured proximity. Third, there must be at least 1 column that contains highly unique values whose pattern corresponds with a system or custom data identifier. 4. Individual cells may contain single token or multi-token values. And 5. The entire data source must not be larger than 4 million rows and 32 columns. Here are the steps for creating an EMDI profile. First, extract and convert the data source to a tabular text file, with commas delimited by the pipe, tab, semicolon, or comma character. Pipe is the preferred delimiter, and note that if your data source fields contain numbers, you should not use the comma delimiter. Secondly, scrub the data in the text file as needed, making sure there is a key column. Third, upload the data source to enforce or to a server accessible to the remote EMDI indexer. This assumes the use of the enforce server for indexing. For details on the remote EMDI indexer, consult the Symantec Data Loss Prevention Administration Guide. Fourth, in the Enforce Administration Console UI, go to Manage, Data Profiles, Exact Data, and then click Add Exact Match Data Identifier Profile. Fifth, specify a profile name, data source, column separator character, and other settings as shown here. Then click Next. Next, classify each column, set an indexing schedule, and save the EMDI profile. To classify columns, drag the slider bar next to each listed column to specify whether the column should be required, which means capable of being associated with a system or custom data identifier, or optional, available for EMDI's mandatory matching on a second column, or whether to entirely ignore the column. Next, under the indexing section, you can choose to submit indexing job on save, or select submit indexing job on schedule, and then specify an indexing schedule. When all this is completed, click the Finish button. Once the EMDI profile has been created, you can decide whether to configure data identifiers to use the profile globally or only in specific policies. For global configuration, go to Manage, Policies, Data Identifiers within the Enforce Administration console. Second, select the data identifier you want to use in policies where you'll be leveraging EMDI as an additional validator. Third, expand the rule breadth, either wide, medium, or narrow, that you specified in your EMDI profile. Note that these settings must match. Fourth, under Validator's validation checks, select Exact Match Data Identifier Check. And fifth, in the box to the right, specify EMDI profile settings. From the Profile dropdown, select the relevant EMDI profile. From the Required dropdown, then select the key required column you designated when creating the EMDI profile. From the At Least Match dropdown, select the number of optional columns from your EMDI profile that you want to match on. Lastly, drag the Proximity selection bar to set the EMDI validator proximity range before and after the data identifier match. By default, an EMDI validator performs a full-text search in a proximity of 50 tokens from a data identifier match, checking each token, except those that are excluded because of ignored columns in the data source, for potential matches. The proximity value can be changed to any value from 1 to 50. After this is completed, click Add Validator to add the Exact Match Data Identifier check to the Active Validators box. After this is finished, scroll back up to the top of the Data Identifiers page and click Save. To configure EMDI for only specific policies, in the Enforce Administration console, go to Manage, Policies, then open the relevant policy. click the relevant data identifier detection rule, and select the same breadth value you specified in your EMDI profile. Expand the Optional Validators tab, and then select Exact Match Data Identifier check. Within the EMDI profile settings, from the Profile dropdown, select the relevant EMDI profile. From the Required dropdown, select the key required column you designated when creating the profile. From the At Least Match dropdown, select the number of optional columns in the EMDI profile you want to match on, and then drag the proximity selection bar to set the EMDI validator proximity range before and after the data identifier match. As with setting a global profile, an EMDA validator will perform a full-text search in a proximity of 50 tokens from a default identifier match, checking each token, except those are excluded because of ignored columns in the data source, for potential matches. The proximity value can be changed to any value from 1 to 50. Note that you can add multiple EMDI profiles to the detection rule by clicking the plus button. When finished, scroll back up to the top of the page and click OK, and then click Save to save the policy. Repeat as needed for other policies. By default, Enforce pushes EMDI indexes to all detection servers, cloud detectors, and DLP appliances. However, to also push the indexes to DLP agents, you must first edit the protect.properties file on all endpoint servers to which the agents connect, as well as on the Enforce server. For Windows machines, the default location of the protect.properties file on endpoint servers is Program Files, Symantec, Data Loss Prevention, Detection Server, 15.5, Protect, Config. On Windows, the default location of the protect.properties file on Enforce servers is Program Files, Symantec, Data Loss Prevention, Enforce Server, 15.5, Protect, Config. Open the file in a text editor, and then locate the line that reads emdi.enabledOnAgents equals false, and then change the false value to true. Also note you can adjust the maximum size of EMDI indexes by altering the number on the emdi.maxEndpointProfileMemory in MB equals 100 line. Be aware, however, that the larger the size you specify, the more memory will be required on endpoint computers to which the policy will be applied. Exact data matching, or EDM, enables organizations to detect personally identifiable information stored in a structured data source, such as a database or directory server, or structured data files, such as CSV files or spreadsheets. The EDM data source can be any type of structured data, but to create the EDM index, you must save the source data as a delimited text file. The EDM index is a secure file or set of files containing hashes of the exact data values from each field in the data source, along with information about those data values. The index does not contain the data values themselves, so it is completely secure. The EDM index is referred to in a policy configured to detect specific combinations of fields from the data source. The detection server uses the indexing algorithm to hash input content, for instance an email, and then analyzes the hashed content against the index to find matches. Configuring EDM to detect and protect exact structured data involves two main tasks: creating an EDM profile, and then applying the EDM profile to a Symantec DLP policy. Exact Match Data Identifiers, or EMDI, are essentially additional validations of data identifier patterns using an indexed data source, which contains specific values for system or custom data identifier types you want to detect in your environment. EMDI is suitable for EDM use cases that involve two or more columns in the data source, with at least one column containing highly unique values for which either a system or custom data identifier exists. EMDI brings some significant improvements to Symantec DLP's exact matching capabilities. One, it is available on all DLP detection channels, including disconnected DLP endpoint agents. This means that EMDI provides exact matching on the endpoint without requiring two-tier detection. Second, it supports blocking, user notification, encryption, and other real-time responses on the endpoint. Third, it is secure and memory efficient, protecting EMDI indexes on the endpoint with strong encryption, and having a memory footprint about 5 times smaller than EDM. Fourth, it supports both system and custom data identifiers. The process for configuring EMDI involves 3 main tasks. 1. Creating an EMDI profile of a structured data source which has been extracted to a delimited text file, preferably pipe delimited. Second, configuring data identifiers to use the EMDI profile, either globally or only in specific policies. And third, changing the setting emdi.enabledOnAgents equals true in the protect.properties file on the enforce server and all endpoint servers. Indexed document matching, or IDM. In this topic, we will describe the indexed document matching detection method and how to use it in a policy. Organizations can generate vast amounts of unstructured, confidential, and proprietary data that take many different forms. Some examples of such unstructured data include design documents, CAD drawings, and financial reports. Symantec DLP's Indexed Document Matching Detection, or IDM, enables organizations to fingerprint and detect sets of unstructured files like these. On detection servers and endpoints running the DLP agent for Windows, IDM supports the following forms of matching. Exact file matching, based on the binary signature of files. Symantec DLP automatically uses this type of matching on all binary files, or encapsulated files, such as zip files, and files it is unable to open and extract file contents from. Partial file content matching is used to detect discrete sections or passages of extracted and normalized file contents. On endpoints running the DLP agent for Mac, IDM supports partial file content matching in the following detection scenarios: moving data to removable storage and network shares using save as operations, and pasting data to browsers or other configured applications. On detection servers only, IDM supports exact file content matching to detect 100% matches of extracted and normalized file contents. The source files to be indexed can reside in any folder that is accessible from the enforce server. Alternatively, you can add the source files yourself to a zip archive and upload it to the enforce server. The methods for uploading the zip file are explained in the Configuring IDM section of this lesson. Symantec DLP indexes all directory contents recursively. That is, it indexes all files in all directories and subdirectories. Symantec DLP cannot index the contents of any zip file embedded inside a zip file. Consequently, if you are zipping the source files, you must ensure that the zip contains only uncompressed, unzipped files. The maximum size of a single IDM document data source index is 2 GB per deployed index on detection servers, which translates to approximately 1 million documents, depending on the size of the source files and their extracted text size. IDM scales to around 7 million documents total per detection server. However, these figures should only be considered a rough estimate. The actual number of documents supported in a single IDM data source can vary greatly, depending on document compression ratios and other factors. On the endpoint, all deployed IDM indexes together cannot exceed 60 megabytes by default, or about 30,000 documents, although this limit is configurable. To protect a large amount of content and files, create separate collections for each set of documents larger than 650,000 files. Organize these files into separate shared directories or zip archives and create separate IDM indexes for each. The IDM index is a hash of exact files and exact file contents created from your document sources, and for partial file contents, a series of overlapping one-way hashes with roughly 30 tokens per hash. By default, these index files are stored on the enforce server at Program Data, Symantec, Data Loss Prevention, Server Platform Common, 15.5, Index. Symantec DLP creates 4 different types of secure binary RDX files, which are loadable images derived from the index file. docsource.rdx is deployed to detection servers. If the document data source is large, the server index may span multiple RDX files. Endpoint docsource.rdx is deployed to DLP agents on the endpoint for exact file matching. For backwards compatibility, legacy endpoint docsource.rdx is also deployed to endpoints who are running version 14.0 and 12.5 agents. Encrypted docsource.rdx is deployed to DLP agents on the endpoint for partial file content matching. Before an IDM index can be created, a document profile must be configured on the enforce server. The profile specifies the document archive, the indexing parameters, and the indexing schedule. After you have created a document profile, Symantec DLP indexes the specified document archive immediately or according to the schedule you have set, and then deploys the appropriate RDX files, docsource.rdx for detection servers, and endpoint docsource.rdx, legacy endpoint docsource.rdx, and encrypted docsource.rdx for DLP endpoint agents. The detection servers and endpoints load the index into RAM when an active IDM policy that references the index is deployed to them. When a Discover scan analyzes a file containing all or part of your IDM document source, Symantec DLP uses the IDM index to detect matches and create an incident. In the example shown here, Symantec DLP has detected content in an outgoing email that matches part of a file in a document source that has been indexed from merger documents. The IDM document index contains a set of hashes, referred to collectively as a fingerprint, which Symantec DLP compares to documents on your network to detect exact or partial matches. An exact match indicates that Symantec DLP has detected the exact file, such as a GIF, MPEG, or AVI file, while as a partial match indicates that Symantec DLP has detected part of the indexed text in input content. Symantec DLP can only perform partial matching on documents that contain text, as opposed to audio or video files, for instance. The IDM index is deployed to all detection servers and endpoints, where it is used for detection. You can refer to the index profile in a policy configured to detect exact or partial matches from the document source. For instance, if a Discover scan analyzes a file containing all or part of your document source, the IDM index enables Symantec DLP to detect the matches and create an incident. Here are the high-level steps for creating an IDM profile. First, in the Enforce Administration console, navigate to Manage, Data Profiles, Indexed Documents, and then click Add Document Profile. Next, select the method for referencing the data source. You have three options for referencing the data source. First, you can upload Document Archive to Server Now, where this option will copy the document source, a zip file containing the documents, to the Enforce server. Click the Browse button to locate and select the data source, and then click Upload Now. When you are using the Upload Document Archive to Server Now option, Symantec recommends that you limit your data sources to 50 megabytes or smaller. For larger data sources, use a third-party solution, such as Secure FTP, to transfer the data source to the server, and select the Reference Archive on Enforce Server option instead. The Reference Archive on Enforce Server option lets you select a document source that is already on the Enforce server. To use this option, you must first use a third-party solution like Secure FTP to copy the document source file to the correct directory on the Enforce server, which by default for Windows or Linux is the file path shown here on this slide. Note that the Symantec DLP user, typically Protect, must be granted Modify permission in Windows or RW permission in Linux in order for the data source files to be placed in these folders. The other option is to use Local Path on Enforce server, where this option lets you specify the exact path, as opposed to a relative path, to a local directory on the Enforce server containing one or more files to index. Do not include the actual file names in this path. Note that you cannot use this method to index documents contained in a zip file. The Use Remote SMB Share lets you specify a set of files on an SMB share. Enter the UNC path for the SMB share that contains the documents you want to index. The UNC path must consist of three parts: a server name, a share name, and an optional file path. Enter a valid username and password for the SMB share, and then re-enter the password to verify it. The Import from a remotely created IDM profile option lets you upload a remote IDM indexer pre-index file to the Enforce server host. The remote IDM indexer is a standalone tool that is run locally on systems where confidential files are stored in order to create a pre-index file, or PRDX. This file can then be copied to the Enforce server for final IDM index generation and deployment. Using a pre-index file frees you from having to collect and copy all the individual files to the Enforce server host for indexing. The remote IDM indexer also includes an Always Keep Files option that lets you incrementally add more data sources to an existing pre-index file so that only new or updated files are indexed during successive indexing jobs. After the document source has been referenced, you can optionally create filters to include or exclude files during indexing. If the file name filters fields are empty, Symantec DLP will index all documents in the specified document source. If you enter anything in the file name includes filters field, Symantec DLP will index only those documents that match the filters. You can also use the file size filters to prevent Symantec DLP from indexing files smaller or larger than the specified sizes. Lastly, you can choose to create the index on save or schedule regular indexing. The schedule can be daily, weekly, monthly, or one time only. Remember that the document source must be on the enforced server for the indexing to complete. Finally, for IDM profiles, Symantec DLP performs incremental indexing. This means that when Symantec DLP re-indexes a share or directory, it only indexes files that have been changed or have been added since the previous indexing. Symantec DLP also deletes any files that have been removed from the document source since the previous indexing. To configure Symantec DLP to detect confidential data against a new IDM index, create an IDM rule and a policy that refers to the index. Here are the high-level steps for creating an IDM rule. First, on the Policies Detection tab, click Add Rule, and then select Content Matches Document Signature From. Then choose an IDM profile from the accompanying dropdown and click Next. Next, give the rule a name and select a default severity level. From the Minimum Document Exposure dropdown, select a value to indicate how the condition should match against the index. You could select either an exact match or a partial match ranging from 10% to 90%. For instance, if you select 70% for the minimum document exposure, a match will occur only if 70% or more of the hashed file content is detected. Note that the content does not have to be consecutive. Symantec recommends starting with a minimum document exposure of 60%. A value of less than 50% will typically result in many false positives. Starting with a rate of 60% should give you enough information to determine whether to go higher or lower without generating excessive false positives. Note also that when the system cannot index the content of a document, an image file for instance, it indexes the document as an exact match only. Additionally, during detection, it overrides the minimum document exposure setting for that particular document and detects only exact matches. Symantec DLP also performs an exact match on very small files, typically those smaller than 300 characters. Lastly, choose whether to count multiple matches and choose which components to match on, whether envelope, subject, body, or attachments. When finished, save the rule and the policy. To summarize, indexed document matching, or IDM, enables organizations to fingerprint and detect sets of unstructured files, such as design documents, CAD drawings, financial reports, and others. IDM supports the following forms of matching on detection servers and on endpoints running the DLP agent for Windows. Exact file matching is used for binary files, or encapsulated files such as zip files, and files from which it is unable to open and extract file contents. Partial or derivative file content matching is used to detect discrete sections or passages of extracted and normalized file contents. Exact file content matching is used to detect 100% matches of extracted and normalized file contents and is only supported on detection servers. The IDM index is a hash of exact files and exact file contents created from your document sources. For partial file content, it is a series of overlapping one-way hashes with roughly 30 tokens per hash. The index is deployed to all detection servers and endpoints and is referenced in DLP policies. Vector Machine Learning, or VML. In this lesson, we will describe vector machine learning and its use cases, as well as learn how to use VML detection rules in policies. Vector machine learning, or VML, enables organizations to detect and protect unstructured data by performing statistical analysis to determine if analyzed content is similar to sample content introduced into the Symantec DLP system. Unlike other detection technologies, with VML it is not necessary to locate and fingerprint all of the data that needs to be protected, nor is it necessary to describe it and risk potential inaccuracies. With VML, the system is trained to learn the type of content it needs to protect based on example documents. VML detection is based on a VML profile. A VML profile is created by uploading a representative amount of content from a specific category of data. The system scans the content, extracts the features, and creates a statistical model based in part on the frequency of keywords in the example documents. At runtime, the system applies the model to analyze and detect content that has features that are statistically similar to the profile. For instance, you might create a VML profile to protect your source code. In this case, you train the system using positive example documents, such as proprietary code that you want to protect, and negative example documents, for instance, open source code that you do not care about protecting. A VML policy references the VML profile to analyze message data and recognize content that is similar to the positive features. The VML profile can be tuned, and it can be easily updated by adding or removing documents to or from the training sets. VML simplifies the detection of unstructured text-based content while providing high accuracy when properly tuned. The key to implementing VML is the example content you train the system against. You must be careful to select documents that are representative of the type of content you want to protect, and you must select good examples of content you want to ignore that are nevertheless related to the content you want to protect. There are two parts to VML technology: training and detection. Training is very similar to indexing for IDM and EDM. During training, a positive set of examples and a negative set of examples are uploaded and provided as training sets or inputs to the training process. VML trains on this training set by using feature extraction to pull out the important keywords that uniquely identify the positive set. It then develops a statistical model or profile that, if accepted, can then be applied to the policy and used for the detection process. At runtime, the system applies the model to analyze and detect content that has features that are statistically similar to the profile. DCM and EDM detection results in matches, while IDM detection results in percentage matches. For VML, however, the detection output is the similarity score that ranges from 0 to 10. If the document is similar to positive example documents, then an incident is created. During the training process, raw data content is uploaded in the form of a zip file. The data is extracted and features are selected and extracted, such as keywords or a group of 2 characters in languages such as Chinese. Features are keywords and phrases that occur frequently in the documents. The system stems the prefixes and suffixes and builds a tokenized vocabulary. It then creates a statistical model by plotting the category and frequency of occurrences for all features. Base accuracy is reported as part of the training process. This base accuracy is calculated using a process called k-folds evaluation. The k-folds evaluation process attempts to measure the quality of the training set based on predicted false positive and false negative rates. If the false positive or false negative rate is high, the classifier can be used to classify example documents. You can classify negative documents to see if they result in false positives. Likewise, you can classify positive documents to verify that they generate incidents with a high similarity threshold. The concept of similarity threshold is covered later in this section. Reporting on base accuracy gives you an early indication of the quality of the training set. In the example shown here, the original training set is 100 documents. Note that in a production environment, a training set is significantly larger. The original training set is then divided into 10 k-folds, or 10 folds. Specifically, the system defines a k-fold as 10% of the entire training set. 9 of these folds are set aside and actually used as the training set. The one fold that is withheld is used as test data to test against the profile as part of training. The 10 documents in this withheld k-fold are classified as true positives, and a false positive and false negative rate are calculated. This process is then repeated against each of the remaining k-folds, each given the opportunity to be the test dataset. A base accuracy rate is calculated for each fold, and all folds are then averaged together. This is not a weighted average. The resulting average is what is reported in the user interface. The most important step in implementing VML detection is collecting the documents used for training. The VML profile and detection accuracy are only as good as the example documents you provide. Unlike other forms of content detection, you do not have to locate or assemble all the data or documents you want to protect, nor do you have to be able to describe them. However, care must be taken in selecting the documents that are highly representative of content that needs to be protected, as well as selecting good examples of document content that does not need to be protected. Narrowly defined categories work best. For example, confidential documents is a broad category, while version 1.1 DLP Java source code is a more effective category because it is very specific. Both positive and negative examples are required, and the ideal negative training set shares some relationship with the positive set. For example, the negative training set can be part of a broader category. The system requires a minimum of 50 documents of each category. However, Symantec recommends a minimum of 250 documents, and that all documents be more or less equal in number and total size, with the maximum size not exceeding 30 megabytes per document. This table lists some example categories and possible positive and negative training sets for each category. Ideally, you will collect about as many negative documents as positive documents. However, this is not always possible. Regardless of how many negative documents you collect, you should seed the negative training set with generic or neutral content documents. Although it is possible to use entirely generic content for the negative training set, this is not recommended. A completely generic negative training set might produce good training accuracy rates in the design phase, but it is likely that at runtime you will not be able to detect the content you want to protect with sufficient accuracy. You can configure a VML detection rule in a policy to reference the VML profile. The profile must be accepted before it can be deployed. All profiles are always deployed to all servers and are always loaded in memory. Note that the profiles stored on the enforced server are not encrypted. The profiles are distributed to endpoints only if associated with a policy and are loaded in memory on the endpoints only if a policy exists. At runtime, the detection engine compares the content from the body or attachment of an incoming message against the profile, and features and model are used to classify a document as positive or negative. If the document's features are statistically similar to the confidential features of the profile, based on the similarity threshold that was set, the system reports a match, and an incident is generated because the similarity score has exceeded the similarity threshold for the VML profile. As mentioned earlier, classification assigns a similarity score between 0 and 10 for unknown detected content. The similarity score indicates how similar the unknown content is compared to the positive example documents. A higher score indicates that the classifier is more confident about its verdict on the detected content. True positives with a low similarity score are a good indicator that incremental training needs to be performed. The similarity score for each component is displayed in the incident snapshot, and you can filter the incident list by minimum similarity score if desired. The similarity threshold is a setting that is configured in the VML profile. An incident is generated only if the similarity score of a positive message is higher than the similarity threshold value. The similarity threshold is used to account for imperfect information in the training sets or example documents. If you set the threshold to 100%, you are telling the system that inbound documents compared against the model in the VML profile must precisely match the positive features in the model. However, because VML detects similar, but not exact document content, a 100% threshold setting does not mean an inbound document exactly matches the model. It would mean that an inbound document has features statistically exact to the model. In general, the higher the accuracy setting, the better the detection results. However, a similarity threshold that is set to the maximum may fail to detect some positive content if it is not an exact match. As mentioned earlier, collecting the documents for training is the most important step in the VML process. VML detection is only as accurate as the documents you collect and upload for training. The accuracy percentages reported to you after the training process completes are specific to the design time training process, and not necessarily indicative of the runtime accuracy rates you can achieve using that profile during actual detection. The profile rates verify the quality of your training set to help you decide whether to accept the profile. After you accept the training, you tune runtime detection by adjusting the similarity threshold. It is important to note that a low similarity threshold value can cause the false positive rate to increase, while a high value can cause the false negative rate to increase. The recommended workflow for implementing VML is as follows. Step 1, create a VML profile. Step 2, upload positive and negative example documents and ensure that the base accuracy is less than 5%. Step 3, accept the profile, keeping in mind that the similarity threshold will default to 0.0. Step 4, use negative testing to determine the initial similarity threshold. For this step, use test corpora that consist of random documents and related but negative documents. Step 5, filter any false positive incidents by similarity score ranges. Step 6, adjust the similarity threshold just above the false positive with the greatest similarity score. In the example shown here, a vector machine learning profile has been created using Medicaid documents as a training set. This profile is then attached to a policy which can be used to analyze incoming and outgoing documents to test for similarity to the training set. The incident record shows the similarity score match, in this case 8 out of 10, along with the highlighted keywords that matched the training set and triggered the incident. A VML profile is required to implement VML detection. After you create the profile, you can use it in any policy as a detection rule or exception. Profiles are stored on the detection server. The high-level steps for creating a new VML profile are as follows. Step 1, in the Enforce Administration console, navigate to Manage, Data Profiles, Vector Machine Learning. On the Vector Machine Learning page, click the New Profile button and then enter a name and optionally a description for the profile. Click Manage Profile to continue with the profile definition. Make sure at this point that you have already collected all of the positive and negative documents that you will be using in the training set. Push the Upload Contents button and then select either positive or negative. VML requires text contents and not binary contents. Any documents that contain binary data are ignored during the training process, and the resulting document count number is reduced. You must upload the positive and the negative document archives separately and indicate which category of documents you upload. Ensure that you select the correct document archive that you told the system you are uploading. If you mismatch the upload, that is, you selected negative but uploaded a positive document archive, the resulting model will be inaccurate. After each upload, a message will be displayed if the upload was successful, and each successful upload will be displayed in the New Documents table, along with whether it was classified as positive or negative. Configure the Memory Allocation option to specify the amount of memory allocated to the training process that runs when you train on the positive and negative document archives. The more memory allocated to the system during the training process, the better the training results. After all the example documents have been uploaded, click the Start Training button to begin the training process. The training process involves scanning the positive and negative documents into the system for evaluation and model creation. The system launches a separate process running outside of Enforce to perform the training. This means that multiple training processes can run simultaneously, and each process runs as a separate process. However, it is important to note that there can be performance issues if Enforce and the processes are running on the same physical device. The profile interface displays the progress of the training process. You can also view the training process from the VML profile page. If training is in progress, the status column indicates training and also displays the elapsed time of the training process. After the training process has completed, a message will be displayed indicating that the training either succeeded or failed. If the process failed, you must retrain the profile. However, you do not need to re-upload the document archives after you have uploaded them initially. It is important to note that if the Enforce server is restarted during the training process will be canceled and must be restarted. From the Temporary Workspace tab, the results indicate the total number of documents and the breakdown of both positive and negative documents that make up the total. The calculated accuracy rates for both base false positives and base false negatives are also displayed. If the training succeeded, you will be prompted to accept or reject the machine learning profile. Make this decision based on the accuracy rate from training that the system displays in the data profile console. As a general guideline, you should reject a training profile with a rate above 5% false positive or negative. After the data profile has been defined and trained to an acceptable state, create a policy and configure a detection rule to use the VML profile to detect or accept content that is similar to the content in the training documents you uploaded. At the Add Rule or Add Exception screens, select the Vector Machine Learning profile. Unlike other detection conditions, the configuration of this condition is based entirely on the profile. There is nothing else to configure at the detection rule or exception level for this condition. In summary, Vector Machine Learning, or VML, detects and protects unstructured data by performing statistical analysis to determine if analyzed content is similar to sample content. Unlike other detection technologies, with VML it is not necessary to locate and fingerprint all of the data that needs to be protected, nor is it necessary to describe the data and risk potential inaccuracies. There are two parts to VML technology. One, during training, a positive set of examples and a negative set of examples are uploaded and provided as training sets. Important keywords are extracted from the positive set and are used to develop a statistical model or profile which can be applied to policies. Second, during detection, Symantec DLP uses the VML profile to detect content with features statistically similar to the profile. It subsequently generates a similarity score ranging from 0 to 10. If an analyzed document is similar to positive example documents, then an incident is generated. Sensitive image recognition. In this topic, we'll discuss how sensitive image recognition works, how to assemble and index image galleries for form recognition, how to set up OCR, optical character recognition functionality, and how to use both form recognition and OCR in policies. Form recognition, or FR, enables organizations to detect confidential information in hand-filled, printed, or electronically fillable forms, such as tax forms, state identification applications, and so on. Symantec DLP's form recognition technology is based on image detection, detecting differences between a baseline graphic, for instance an image of a blank form, and modified versions of that graphic. Because form recognition is highly processor and memory intensive, it is performed on the detection server. Once form recognition indexes and policies have been deployed to detection servers, Symantec DLP detects modified versions of indexed forms attached to an email, copied across the network, or stored on a file share. It then generates incidents and blocks emails or file copy operations, or quarantine files according to the response rules you have created. Symantec DLP can perform form recognition on images in the following formats: JPEG, PNG, TIFF, both single-page and multi-page, bitmap, BMP and DIB forms, hard copy XFA, with soft copy XFA fillable forms not supported, standard PDFs, version 1.2 or later, and PDFs in Acroforms format, as well as Microsoft Office documents. Form recognition is available for Network Monitor, Network Prevent for email, Network Prevent for web, and Network Discover on detection servers. It is not available for Endpoint Discover, Endpoint Prevent, or any cloud detectors. This figure shown here provides an example of how a form recognition incident is captured and then displayed in the Enforce Administration console. There are three primary steps to configuring form recognition in Symantec DLP. First, gather and archive blank forms. Second, create a form recognition profile. And third, use form recognition in a policy. We'll discuss each of these steps in more detail here in this lesson. Form recognition is enabled by default on DLP detection servers, and the first step in preparing to implement form recognition is to gather PDF versions of the forms you want to detect. The forms must be in single-page format. For example, if you want to include a tax form that spans multiple pages, you must break out the form into multiple PDF files, each file containing a single page of the form. After you have gathered all the forms you want to detect, archive each category of forms in separate zip files. For instance, all federal tax form pages in an IRS taxforms.zip file, and all state license application forms in another zip file, and so on. These zip files must be flat archives. That is, the zip file cannot include any other folders or directories, not even a root level folder. For best results, ensure that forms meet the following criteria. 1. The PDF files containing the form images should be at least 200 dpi. Second, forms with electronically fillable fields must be in Acroform format. Other interactive form formats are not supported for detection. Third, each form should have a sufficient amount of text and graphical content. Sparse forms can cause more false matches. Fourth, each form should contain unique content. Forms that share very similar content are harder to match and could cause more false matches. For instance, tax forms from 2014 and 2015 share many similar features and would be difficult to detect if they were in the same profile. Fifth, the content of each form should be evenly distributed across the page. Forms with clustered content and sparse areas are more difficult to match. Lastly, each form should have either white or light-colored backgrounds. Black or dark backgrounds are not supported. To associate the baseline forms with a policy, you first create a form recognition profile that points to a zip archive you created, referred to as an image gallery in the Enforce Administration console. When you save the profile, the zip gallery is uploaded to the Enforce server and indexed. In Symantec's test environment, Symantec DLP has demonstrated it is capable of supporting up to 500 images across all image galleries. However, a detection server with more cores could potentially handle more images. For faster matching performance, create fewer profiles with a larger number of forms in each gallery. For instance, creating a single profile that includes a gallery of 100 PDF files results in 5 times faster detection speed than having 5 profiles with 20 PDFs in each profiles gallery. The high-level steps for creating a form recognition profile are as follows. Step 1. In the Enforce Administration console, navigate to Manage, Data Profiles, Form Recognition, and then click Add Profile. Second, give the profile a name and, if desired, a description. Step 3. Specify a filling threshold value from 0 to 10. A value of 0 indicates that minimally filled out forms, for instance ones with only 1 or 2 fields filled in, will still result in a match, while a value of 10 indicates forms must be mostly or completely filled out for a match to occur. When finished, upload the gallery zip file you created and then save the profile. Afterwards, click the Refresh button in the Enforce Administration console until the profile state is listed as Profile Indexed. Additionally, the usable forms count value should be equal to the number of PDF files you included in the gallery zip file. Once a profile has been created, you can configure Symantec DLP to detect forms filled out with potentially confidential information by adding a form recognition detection rule to a policy. Here are the high-level steps for creating a form recognition rule. Number 1, on the Policies Detection tab, click Add Rule, then select Detect Using Form Recognition Profile, and then choose a form recognition profile from the accompanying dropdown. Click Next, then give the rule a name and select a default severity level. Then click Save. Symantec DLP can perform optical character recognition, or OCR, on data at rest and on network traffic. Using OCR, Symantec DLP can extract text from PDFs, for instance, files created by scanning paper documents and saving them in PDF format, as well as Microsoft Office documents, along with JPEG, PNG, TIFF, single-page and multi-page, and BMP images, and then analyze the extracted text against your DLP policies. Use cases for OCR include performing detection on text extracted from digitized documents, applications, photos, and diagrams or figures. The DLP products that can perform OCR are Network Discover, Network Monitor, Network Prevent for email, and Network Prevent for web. There are several advantages to using Symantec DLP's OCR capabilities, rather than integrating DLP with another third-party OCR solution. The most obvious advantage is that OCR is fully integrated with Symantec DLP and supported by Symantec. Additionally, Symantec DLP's OCR solution is implemented as a lightweight microservice that supports flexible deployment options. The solution also includes image pre-filtering and automatic performance tuning features that decrease latency and improve bandwidth usage. Finally, a thumbnail of the original image is included in the incident snapshot to assist with remediation and record-keeping efforts. Symantec DLP 15.5 requires a sensitive image recognition license, which enables both OCR and form recognition. Detection servers for the supported DLP products send OCR requests, such as images and some related information, to one or more OCR servers deployed on the network. For low-traffic environments, it is possible to send all OCR requests to a single OCR server, but for environments with heavier traffic, it is more effective to implement a bank of OCR servers to which OCR requests are distributed by a load balancer, as depicted in this figure. OCR servers, which must run on Windows, receive OCR requests, extract any text from images, and return the text to the detection servers for analysis against your DLP policies. When a DLP detection server is configured to work with OCR, several components are enabled on the server. One of these components is the image pre-filter, whose purpose is to automatically and intelligently analyze images to see if they are suitable for OCR, and if so, to recommend the most efficient OCR processing mode, whether dynamic, accurate, balanced, or fast, for each image. This helps ensure that the OCR process is as fast and efficient as possible. Another component is the OCR client, which sends requests to and receives responses from the OCR server or servers. OCR servers, whether they are virtual or physical, should not run other applications. In other words, they should be dedicated just to OCR. Additionally, OCR servers have different hardware, operating system, and server settings requirements than the Enforce server and detection servers. This table shows a summary of OCR server system requirements. Note that in a hyper-threaded environment, the number of logical cores is twice the number of physical cores. In a virtualized environment, the number of logical cores is the same as the number of vCPUs assigned to the VM that runs the OCR server. Also note that the total required memory is a function of the number of hardware threads and logical cores, and consequently, the number of concurrent threads configured to run on that host. For instance, for a VM running with 8 logical cores, or vCPUs, the total memory required for an OCR server is 3 gigs plus 200 megabytes times 8, which equals 4.6 gigs total. To assist organizations to better understand their OCR needs so they can deploy an adequate number of OCR servers in their environment, Symantec has designed a process for measuring image traffic data and has also provided a tool to calculate OCR server sizing requirements. The process involves modifying the OCR.recordRequestStatistic setting on a detection server and then letting the server run for 1 or 2 days so Symantec DLP can collect metrics on the images it encounters in your environment. The results are logged in the OCR requests record0.log file for the last 24 hours. No incidents are created, and only images that are suitable for submission to OCR are counted. Additionally, Symantec has provided an OCR server sizing estimator spreadsheet that lets you enter values from the OCR requests record.log file to help you calculate the number of OCR servers you should deploy per detection server, based on the metrics gathered in the log file. You can download this tool from the support.symantec.com website. To run the OCR diagnostics, first in the Enforce Administration console, go to System, Servers and Detectors, Overview. Then click the name of the detection server you want to use for the diagnostics and click Server Settings. Locate the OCR.recordRequestStatistic setting and set it to True. Then scroll back up to the top of the Advanced Settings page and click Save. Next, run a scan on a typical data source. If you are scanning data in motion channels, such as Network Prevent for email, Network Prevent for web, or Network Monitor, you need to scan for as long as it takes to collect a significant sample of data for the OCR requests record0.log. For Network Discover, you might try scanning a typical data source, but other approaches are also possible. For more details, see the Symantec Data Loss Prevention OCR Server System Requirements and OCR Server Sizing Estimator article on the support.symantec.com website. Once the scan has completed, download the OCR requests record0.log file from the Enforce Administration console. To do this, go to System, Servers and Detectors, Logs. From the drop-down on the Collection tab, select the detection server where you ran the OCR diagnostics. Place a check mark in the Operations Logs box associated with the selected detection server and click Collect Logs. Use the Enforce Administration console's Refresh button to refresh the page until a download link appears for the requested logs. Click Download and then save the log collection zip file to a readily accessible location. Then extract the contents of the zip file. Go into the Symantec DLP logs/detection server name/logs folder in the file system and open the OCR requests record0.log file in a text editor. Make a note of the following values from the text file: percentage of messages containing images that need OCR, and average number of OCR images per message. Lastly, go back and change the OCR.recordRequestStatistic setting back to false, so that the detection server can resume normal OCR processing. To use the OCR Server Sizing Estimator spreadsheet, first download the spreadsheet from the Symantec support website and open it. Then select the sheet that corresponds to the number of message chains you want to estimate for. In the green shaded cell to the right of the text percentage of messages containing images requiring OCR, enter the percentage of messages containing images that needs OCR value from the records request log created during the previous diagnostic scan. In the green shaded cell to the right of the text maximum acceptable rate of OCR message timeouts, enter whatever value is acceptable to your organization for the maximum percentage of timed out requests to OCR servers that may occur if the servers are at full capacity handling OCR requests. In the green shaded cell to the right of the text estimated average number of images per OCR message, enter the average number of OCR images per message value from the diagnostic log earlier. The recommended number of OCR servers that you should deploy per detection server to effectively handle the load of OCR amenable content in your environment will now be displayed in the blue shaded cell to the right of the text number of OCR servers per detection server. To install the OCR feature, first, in the Enforce Administration console, go to System, Settings, General, and then apply the Sensitive Image Recognition license, entitled Sensitive Information Recognition.slf. Next, install one or more OCR servers on Windows hosts on your network. To do so, copy the OCR server installer 64.exe file to the machine or machines where you want to install the OCR servers. Then run the file and complete the installation wizard. Note that if the wizard prompts you to install Java Service Wrapper from Tanuki Software or any other software, allow the installation. Next, verify the installation of the OCR server software. Open the Windows Services Management console and confirm that the service entitled Symantec DLP OCR Server is running. Then, navigate to the OCR Server software installation directory, which by default should be C Symantec DLP OCR protect logs. Then open the OCR server.log file and confirm the presence of the following entry: info com.symantec.dlp.ocr.server.ocr server-OCR server started. To configure the OCR feature, first modify the ocr.properties file on the OCR server, which is located by default at C Symantec DLP OCR protect config. First, set the value of num.ocr.workers to equal the number of logical CPU cores on the OCR server. For instance, if the OCR server is running on a quad-core CPU in a hyper-threaded environment, you would specify a value of 8 for num.ocr.workers. Next, set the value of server.tomcat.maxthreads to equal the value of num.ocr.workers plus 1. For instance, if the value of num.ocr.workers is 8, you would specify a value of 9 for server.tomcat.maxthreads. Next, create one or more OCR engine configurations, which are connections to OCR servers. In Enforce, go to System, Settings, OCR Engine Configuration, then click Add OCR Engine Configuration, then specify a name and description for the OCR engine configuration. In the OCR server hostname field, specify the hostname of the OCR server, or if you are using a load balancer to distribute the workload across multiple OCR servers, put in the hostname of the load balancer. In the port field, specify the port on the OCR server where OCR requests will be received. The default port number is 8555. In the OCR engine timeout field, specify the maximum amount of time in seconds for text extraction, starting from the moment the request arrives at the OCR server. The default timeout is 30 seconds. The timeout is how much time the request is allowed to spend inside the OCR server and does not include transit time or other delays. As with other content extraction operations, if the timeout is reached, the OCR component is skipped, and the previously extracted content moves on to detection. In the Accuracy versus Speed section, select the OCR processing mode. The available options are Accurate, which is precise but slow, useful for medium resolution images or screenshots; Balanced, Fast, which is suited for very clean scanned documents; and Dynamic, the default and the recommended option, where the detection server's built-in intelligence will decide which OCR processing mode, accurate, balanced, or fast, is best for a given document. In the Supported Languages section, select the languages that the OCR server should evaluate. You must select at least one language. Languages listed under the heading DLP Detection Languages are supported for detection, while those listed under Other Languages are given a best effort. In the Specialized Dictionary section, select any dictionaries the OCR server should use to help it recognize specialized medical, legal, or financial vocabulary. Symantec DLP ships with specialized dictionaries in Dutch, English, French, and German. If you have created a custom dictionary to help the OCR server recognize unusual words or proper nouns, provide the name of that file in the Custom Dictionary field. The requirements for custom dictionaries are as follows. The format of the file must be plaintext.txt, words must be separated by new lines, and the text file must be copied to the C Symantec DLP OCR protect bin directory on the OCR server. When all of the above options are completed, save the configuration. The next step is to assign the OCR engine configuration to a detection server. To do so, in Enforce, go to System, Servers and Detectors, Overview. Click the detection server to which you want to assign the OCR engine configuration and click Configure. On the OCR Engine tab, from the OCR Engine Configuration dropdown, select the OCR configuration you want to assign to the detection server. Note that it is not necessary to restart the detection server after assigning an OCR engine configuration. When finished with the configuration, first press Save and then click Done. Symantec strongly recommends that you replace the default key store installed with the OCR server, used for authenticating with detection servers, with your own key store. To do so, generate your own key store and install it on the OCR server host at C Symantec DLP OCR protect key store. Then, on the OCR server host, go to C Symantec DLP OCR protect config. Open the OCR.properties file and modify the following parameters to reflect the new key store. Server.ssl.keystore should contain the key store location. Server.ssl.keystore password contains the new key store password. Server.ssl.keyalias contains the certificate the OCR server passes to the detection server. The default is OCR server. In summary, form recognition detects confidential information in hand-filled, printed, or electronically fillable forms, such as tax forms, state identification applications, etc. Form recognition is based on image detection rather than OCR technology. It detects differences between a baseline graphic, for instance an image of a blank form, and modified versions of that graphic. The first step in implementing form recognition is to gather the forms you want to detect in PDF single-page format, and then archive each category of forms in separate, flat zip files. To associate the baseline forms with a policy, create a form recognition profile that points to a zip archive or image gallery. Symantec DLP can also perform optical character recognition, or OCR, on data at rest and network traffic. Using this technology, Symantec DLP can extract text from PDF files, for instance PDFs created from scanned paper documents, and Microsoft Office documents, as well as JPEG, PNG, single-page and multi-page TIFF, and BMP image formats, and analyze the extracted text against your DLP policies. For low-traffic environments, it is possible to send all OCR requests to a single OCR server, but for environments with heavier traffic, it is more effective to implement a bank of OCR servers to which OCR requests are distributed by a load balancer. Implementing Symantec DLP's OCR feature involves installing OCR server software on one or more Windows hosts, then creating an OCR engine configuration in Enforce, and assigning these configurations to detection servers. Custom file type detection. In this topic, we'll discuss the purpose of the file type analyzer utility and identify where you can go for details about downloading and using the utility. The file type analyzer utility enables you to analyze custom file types that Symantec DLP does not recognize out of the box. This utility helps you find the commonalities and attributes that describe a custom file type. This data is often referred to as magic bytes because they are unique characters that positively identify the file type. The file type analyzer is a standalone Java application that features a graphical user interface. This utility will enable you to perform the following operations: read in a collection of files from a directory or directories called the dataset, view and compare the unique bytes for each file in the dataset, analyze the bytes across files and identify those that are consistent, test a custom file type detection script, and then save and open dataset configurations and test scripts. For detailed instructions on obtaining, installing, and working with the file type analyzer utility, refer to the Symantec DLP Detection Customization Guide, available at the displayed URL. In this lesson, we discuss the challenges that organizations face in trying to identify and protect important data buried among the vast amounts of information that pass through network environments every day. An effective approach to identifying confidential data in an organization is to build a task force centered on solid leadership and informed by input from key stakeholders across the organization. Because it is not possible to immediately begin protecting all data at once, it is also a good practice to prioritize data based on the level of impact its loss would have on the organization, and then focus on protecting that data first. Using Symantec DLP policies and detection technologies, organizations can detect and subsequently protect their confidential data wherever it may exist. Policies include detection rules to match data content, classification, context, or properties, group rules to target specific groups of users, and response rules to notify about, escalate, resolve, and dismiss incidents, and to block, quarantine, or encrypt content when a policy violation occurs. To review, the detection technologies or methods included in Symantec DLP to enable organizations to detect confidential data are as follows. Described content matching, or DCM, detects structured and unstructured data using keywords, lexicons, pattern matching, classifications, contextual attributes, file types, file sizes, sender, recipient, and network protocol information. It is best for detecting unstructured files and file content, or detecting email messages and common document file types, tagged with Semantic Information-Centric Tagging, or ICT, metadata. Also, for dealing with situations where it is difficult or impractical to collect all the content to be indexed. Exact matching includes exact data matching EDM and exact match data identifiers, or EMDI. These are used to create an index of structured data sources, where EDM and EMDI indexes can be referenced in policies to detect information contained in outbound emails, or files residing on Windows file servers, etc. It's best for detecting high-priority confidential data that originates in databases, CSV files, spreadsheets, and directory servers. Indexed document matching, or IDM, creates an index of unstructured data sources and can be used for detecting unstructured confidential files or file content, whether exact or partial, that users attempt to send as attachments to email or copy to unauthorized locations, such as internal file servers, endpoint storage, or cloud storage. Vector machine learning, or VML, is used to detect unstructured data by performing statistical analysis to determine if analyzed content is similar to sample content uploaded to the Symantec DLP system. It can be used to detect confidential text-based data without having to locate, fingerprint, or describe the data. Sensitive image recognition detects differences between a baseline graphic, such as an image of a blank form, and modified versions of that graphic, and it can extract text from images and analyze extracted text against DLP policies. It can be used for detecting filled PDF forms, Microsoft Office documents, and images of documents containing confidential information. Sensitive image recognition includes both form recognition and optical character recognition, or OCR. Custom file type detection uses the File Type Analyzer utility to identify commonalities and attributes that describe custom file types. It can be used when analyzing custom file types that Symantec DLP does not recognize out of the box, in order to develop custom file type detection scripts. For more information on these topics, you can consult the Symantec Data Loss Prevention Administration Guide or the Symantec DLP Detection Customization Guide, as well as the general help found at support.symantec.com. Thank you for joining us. This concludes the Identifying and Describing Confidential Data module of the Symantec Data Loss Prevention 15.5 Administration course.